Hello, welcome back to part 2 of Python 9. We're covering the rolling average graph in this part. Let's begin. Here we are. All right, in the last one, we covered how to make a fill-between graph. We used standard deviation as our example. We made this shaded graph here. So we're covering the rolling average graph now. We're going into a bit of detail, quite a bit of detail, because you need to understand how to make this function and how we make a window and how we move it along as well, and how to make sure that we move along by the correct amount and make it stop at the right place. That's our aim. And our aim is to finally show you at the end of the video what a rolling average graph looks like. It's going to be similar to the Gaussian filter. It's going to have a similar effect. It's going to smooth out your graph. It's going to reduce high frequency noise. So let's begin. What is a rolling average graph? Well, a rolling average graph means to take the mean of a small window of your data and then plot that mean on your graph. The window then moves forward over your dataset to take into account the next data point. And once again, calculates the new mean and then plots that point and continues. There's a side effect of the rolling average graph, which is the length of your mean data points is shorter than the original data set. When the start of the window reaches the end of the data set, then the graphing will stop. The window does not have enough values to move forward, so the values are not included in your final list of means. If you imagine we have our window here, okay, and our window is moving along like this. Apologies. It's moving along like this, and it reaches the end here, and it can't go any further. There's no more values for it to move into. So all the entries in this window here do not get graphed. So you're going to be missing the number of entries equal to the size of your window. You'll see it if you play around with putting on extreme inputs into your rolling average graph, and you'll see what it does. So let's begin with the mean. So how do we find the mean? We know we add up the numbers and then divide by the number of numbers. So we're just taking numbers from our window, which is going to be the same size every time, so we will always be dividing by the same number. We also have a function in Python, sum, that will sum up our numbers once we have our window slice. So, slicing windows, we will need to approach taking a window with a bit of foresight and some knowledge of for loops as well. So we're going to cover the range function here. The range function only requires one parameter really, a stop parameter, which is very similar to slicing, where we put in the stop parameter, and that tells us where, the first index that we don't want included in our slice. But we're also going to include a starting index as well, or a starting number rather. Range doesn't really work on indexes. It's just that we're going to use the output of range to take a slice. So it returns a list of numbers that count from start to stop. By default, start is 0, but a stop value is required. And it's identical to slicing. Range does not include the stop number in its values that it returns. This will be very important when we are dealing with range and slicing with stop at the same time in a wee moment. So we're going to use range in the for loop to count through our numbers. And then this counting is going to move our window when we slice our data set. So here's an example of what range does. I've got a for loop here for I in range 7. Okay, so range 7 is going to count up from 0 up to 6. So we're going to get 7 numbers out, and I is going to print out 7 numbers. But as you can see, we don't actually get 7, because in computing science, we start counting from 0. And I here, I takes on the values that are in range. So range returns, 0, 1, 2, 3, 4, 5, 6. And in each for loop, I takes on a new value. And I'm printing out I, and you can see, I could also print out I, and say I could print out I with it as well. You can see it's going to print that out. But if I print out, say, I and I plus 1, well, you can see it's indeed printed out 7 numbers, but these are the actual values. So that's just a wee example there of what the for loop does and how I takes on values each time. It takes on a new value of each iteration of the loop. So now we're making the window. Let's think about our window and where it's going to start and where it's going to stop. Just ignore this cell here. I'm actually only interested in the output of this to show you a visual sort of example of what it looks like. So our window size is 3, n equals 3, n is the size of our window. We've got our list up the top here, our example list. It's got 7 numbers in it. It begins at 1 and it ends at 7. And then we've got the indexes down below. The indexes start counting at 0 and they stop counting at 6. Then we've got the window down below. So the window is encompassing these 3 numbers at the start, 1, 2, and 3. the starting index is I equals 0, and the ending index is I plus n, which is equal to 3. So when we're making our loop, we're actually going to start counting from the back. So this should actually be just I, and this should be I minus n. So if I is equal to n at the start, and then if we take away I minus n, we're going to get back to 0. We're going to basically use the for loop and this I variable, and we're going to put this into a slice. So we're going to use variables to control where we slice in our list. Okay, so we have shown that we can use indexes to define our window. Our window will begin at I minus n, and it will end at I. So slicing excludes the stop index from being in the list. So we're not going to worry about I taking us outside of the window size. We're basically going to use range to give us the value, the stopping values. Okay, we're going to use range to give us the stopping values of our slice. And that means that if we start range at the first index that's not going to be included, so that's going to be 3. So if we start counting at n, then to begin the window size, we just need to go n spaces back. So we start at the end of the window, we go back the size of the window, and that takes us to the beginning of the window. Does that make sense? So I is going to count up each time, and every time I moves up, well, this number will move up to 4, and this number I here is going to move up to 1. If I is equal to 4, then we've got 4 here. Take away the size of the window again, it's going to take us down to 1. So this will have moved up to 3, and this will have moved up to 1. And so we're going to now be counting 2, 3, 4 in our window. So that's what we're going to be doing with our range, and we're going to be putting that into a slice. So I'm just going to quickly show you a bit of a problem with range, and I'm going to show you the fix for it as well. So because range works like indexing and the stop value is not included, if you see here, I am taking a slice of the final 3 entries, the last 3. So that's going to be 5, 6, and 7. That's indexes 4 to 6. If I take indexes 4 to 7, I'm actually going outside of the list. And you can see I get those last 3 values. That works, that's good. But if I take just the last index in the list, then I actually don't get 7. Because this index 6 is excluded, then I don't get the value that I want. And that's not good. So we actually need to go outside of the list indexes in order to do this correctly. So we can't use the last index as a stopping point as it excludes the last entry. So we're going to go outside of the list indexes. The final index is actually 1 less than the length of the list, and this is really convenient for us. So we have a function that's going to work on all inputs now. We can use length, and that's going to work on all inputs. If we use length to define the stopping point, then all we need to do is just put length into range, and surely that should work. So I've got a bit of code here. Just ignore that and look at the output here. So the list length is 7, the window size is 3. This is the example list down below, and the missing entry is 7 in here. So when I do example 4 to 6, the stopping value is 6, we miss 7, that's not good. And now in this one down here, I'm doing 4 to 7, and the stopping index is now 7, and we get the full list. That is good, that's very good. And in the final example here, I've used L, and L is equal to the length of the list. Example is the name of the list. And when I do that, you can see I get the same thing as when I use 7 as a stopping point. So we can use the length of the list as the stopping point, and it will get us the correct window slice. It's going to work. So obviously our slices are going to be made with variables, not numbers. So we're going to use a for loop and an iterator variable, that's I, that holds values given by the range function. So our function needs to work for any input that we give it, so we should use the properties of our input to define the behavior of our function. So the properties that we can use are the length of the list and the window size as well. This is going to help define the behavior of the range function and our ruling function as well. We could have the stopping point of range be the length of the list, but this means it will only count up to the last index in the list, not the length of the list. So remember, range starts counting at 0. So if the length of our list is 7 and we put 7 into range, the highest number that we get out is 6. And then if we were to take that number 6 and put it into a slice for the stopping value, then obviously it's not going to include that in the slice as well. So we need to bump it up by 1. We need to add 1 to account for this error. So when we do that, our stop expression in the range function here is L plus 1. That's the length plus 1 more. So we get 8. So when we put 8 into range, what it returns to us is And we're also beginning our we're beginning our range at n as well, and n is equal to 3. So we're beginning at 3, it goes 4, 5, 6, 7, it doesn't go up to 8, so the range does not return the stop value of 8, but it does return 7 to us here because we've added on 1. So because we've added on 1, we can now put 7 into our slice, and for the final slice window that we take, the stopping value is going to be 7, and it's going to take us outside of the list. It's just making sure that we stop at the right place and we begin at the right place as well. It's going to make sense when I show you the rolling function here in a wee second. Just the last wee bit. Our range begins at n because I is in the stop parameter for our slice. So the start value for our slice must be I minus n in order to remove the size of our window and start at the correct index. The example list here is 1 through 7. And observe that if I is equal to n, so if I is equal to the window size 3 to begin with, then we're doing a slicing operation here. So on example, we want to start at I minus n. So if I is equal to n, I minus n is just I minus I, which is 0. And I in here will be equal to n, so we're going to have 3 in here. It's equivalent, I'm just showing that it's equivalent to this thing here. We get 0 here and we get 3 here, and this is the first slice of our window. I'm showing the connection between using variables, sort of basic algebra, to define the behavior here. And because it's a loop, it's going to work each time as I moves up the list. We want this window to move with us. So we've got our example list, the index is below. I'm just showing you we've got the expression here for I. I've set I equal to n at the beginning as well, so that when we put this in, it's equivalent to slicing at 0 and stopping at 3. So that was the explanation for the rolling average list. I know that was a lot. Please go and rewatch that again if you're not understanding, or if you think it might help to see the function itself, then this is it here. We're defining a rolling function. We're taking in the array, or a list, as an input. N is the window size. We're making a new list to hold our calculated mean values. We are defining the length of the list in L. We are setting up our range, our for loop in here. It's going to start with n, and it's going to go up to the length plus 1 to account for that excluding of the stop value. This is where we take the window slice. So each window slice in the new iteration of the for loop will be applied to this. Remember, we can rewrite over variables as well. So when we go into a new iteration, then when we take a new slice, whatever's in window slice just now is going to be rewritten over. So we're not going to have to deal with the previous windows. So we're beginning at I minus n to start with. That's going to be 0. And I is just whatever value of range it's taking on. We're calculating the sum of that window slice then. And then after we've found the sum, we take the total sum, we divide it by the number in the window slice, so the size of the window slice, and then we append that into the average list. And then it's returning the average list to us. So if we have our list here, or an array list, in this case it's the same thing, it doesn't matter, there's no difference. So we're printing it out, and I want to find the rolling average with a window size of 3. So it's going to take 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, and then 5, 6, 7 finally. And it's going to calculate the average of them. So 1, 2, 3, what's the average of that? We'll add up 1 plus 2 plus 3 is 6, and then divide that by 3, we get 2. And this is what we put in as the first value. Then we go over to the next window, we do 2 plus 3 plus 4, and what we get from that when we divide by 3 is 3 in here. And we do that until we get to the end, the final window slice. And we've defined the final window slice by L plus 1, which is the length. So no matter how long of the array we put in. So for example, I can increase the length. I'm going to put in 8, 9, 10. I've increased it, and look, it still works. Because we've used a property of our list, we've used the length, and we've used the window size, then it's going to work for any input that we give it. That's good. We want our functions to work for anything that we throw at it. I can change the window size to 2, and you can see 1 plus 2, what's halfway between 1 and 2? Well, 1.5. 0.5 is between all of these numbers, and it goes all the way up. That's how you make the rolling function. That's how you take a slice of your window. I know it's very confusing. It's the first time using for loops in a sort of advanced way. I'm just going to show you how to plot it now. We take our data sets, we plot with the rolling function and here is the value to be plotted. And when we do that, you can see we've got our Dallas at the top here and we've got our PT1000 down the bottom. You can see there's a bit of a calibration error in the PT1000 because it's sort of slightly below the more accurate Dallas digital thermometer. The PT1000 is an analog thermometer. It's not, it doesn't have great resolution. It's not very reliable. So there's a bit of a calibration error. So if we look at the unfiltered graphs below, you'll see it's much harder to analyze. Look at this very messy data. We are able to estimate the calibration error just by looking at this graph. So you can see up here, the Dallas is about 22.6 here and about 22.3 in the same place. So it's maybe about 0.2 to 0.3, I'd say, on the calibration error. On this, how on earth would you estimate the calibration error on this? It's not possible. That's why we use our filters, so we can analyze our data reliably. So there's no way we would be able to do that with this graph here. No way at all. And if we wanted to calculate the calibration error, we can actually do that here. And it says it's about 0.4 as an average all the way through. So maybe if you raise it up by 0.4, on average, it would be about the same. That's just an example of how you might find the calibration error using some functions here. This is the end of Python 9, part 2. Up next is going to be the last episode, Python 10, on defining functions. It's going to be a special episode for the finale, and it's going to help you out in your labs and for future as well in physics on making your own functions to do things for you. Thanks very much for watching, and I will see you in the final episode. Bye.